All right. For the achievement test here, the other day we talked a little bit about Pythagorean Theorem. But basically, Pythagorean Theorem works on right triangles. Okay? It only works on right triangles. It doesn't work on anything else. There's other triangles have a lot of special formulas that you'll really learn in geometry, a little bit in algebra, but they have special ways that you can figure out dimensions of triangles. Okay? That is what Pythagorean Theorem is. Pythagorean Theorem is basically a way to identify missing lengths of sides. Okay? So for example, if we have a 90-degree or a right triangle, okay, and you got your box, of course the little square means 90 degrees. All right, now you have A, B, C. Okay, understand that this could also be B, A, C. Okay, the side across or opposite of the 90-degree angle is called the hypotenuse. Okay, the hypotenuse is the longest side of the triangle, as well as the side opposite of the 90-degree angle. Okay, so the longest side is the hypotenuse. It's the side opposite of the 90-degree angle every time. Okay, doesn't matter how the triangle's flipped. You find the 90-degree angle, you look across, that's C, the other two sides are A and B. Does not matter which side is A and which side is B. Okay, so for example, if I had this triangle here, okay, and they say that's the 90-degree angle, then this is C. Okay, and the other two sides are A and B. Doesn't matter which is which. Okay, so the main thing is you find the hypotenuse, and then the other two sides have to equal it. Now, the actual Pythagorean theorem says this: if we take A squared plus B squared, it has to equal C squared. So if we take the two shorter sides and square each one of them, and then add it together, that total will equal the total of the longest side squared. Okay? Now, for example, if I had this right here, if I had, let's say this is 12, this is 20, and we don't know B. Okay, to figure that out, we just use our formula. Use the Pythagorean theorem, and so that's, once again, I'm going to put it right underneath here so we know it's applying to this one. Okay, I just plug in the information. I plug in that there, and I plug in the 20 there. So that's 12 squared plus B squared equal 20 squared. Okay. Now, not all of these are going to be a nice little, whole number. Some of them are going to be, you're going to have to approximate around them. Okay. So you're going to have to do what we did last night to it. All right. So if we look at this one, 12 squared is what? 144. 12 times 12. Plus B squared equal, what's 20 squared? 400. Okay? Now, when I'm at this point, I have to take and get B squared by itself. To get B squared by itself, I have to do the inverse of addition, which is subtraction. So I'm going to subtract 144 from each side. Okay, when you subtract 144 from each side, it cancels on the left side. On the right side, that leaves me with what? 256. So now I have b squared is equal to 256. So I have to take the square root of that and the square root of that. Okay? Now, the square root of 256, you should have memorized. What? 15? No. No. You should have it memorized. If you have it memorized, you shouldn't have a tenth. You shouldn't have to approximate it. It is a perfect square. No. 16. 16. Now, remember, the key. So what does it end in? Remember, if I have 17 squared, that's going to end in a 9. If I have 18 squared, that's going to end in a 4. If I have 19 squared, that's going to end in a 1. Okay? 16 squared obviously ends in a 6. All right, so this is 256. That's going to be at 289, I believe. I know this one is 361. Is that right? 35. Yeah, I think so. I think this is 324. I don't know. That doesn't look right. 324. Yeah, it is. Okay, I did remember it. So those are those perfect squares. Okay. So make sure you need to really know those. So when you see it, you don't have to really think about it. You know it, boom, it's that. Okay. And so what they're saying then is this. They're saying that B here is 16, whatever we had, 16 centimeters, whatever. Okay. This particular one was feet. So it'd be 16 feet is what B is. Okay, so if you're looking for A or B, you're going to take something from the A or B side and subtract it from both sides. All right? Now, let's look at one. Let's look at one that is not a perfect square. Yeah, let me change that. That doesn't look like what I want to do. Okay, so what are we missing in this picture? A, B, or C? What? C, as in cat. We're missing C. So, that means either one of these are A and B. Okay? So that means 5 squared plus 10 squared equals C squared. And why I say that either one of those is A and B, because that's the same expression. Okay? That's the same expression. So it doesn't matter which one I made A, it doesn't matter which one I made B. All right? Now, so as we look at this, 5 squared is 25, plus 10 squared, which is 100, equal C squared. Well, that's 125 equal C squared. So to solve that, I've got to take the square root of both of them. That leaves me a C over here, and 125, unfortunately, is not a perfect square. Okay? 125, the square root of 125, falls between the square root of 121, which is 11, and it falls between the square root of 144, which is 12. So somewhere in here lies the answer. Now, is 125 closer to 121 or closer to 144? Well, obviously 121. Okay, it's obvious, it's fairly close. So I want to look at 11.1, 11.2, and probably 11.3. Yep. Do what? You know the answer? Okay, we'll just hang on to it. Now, it's going to be one of those three, so I'm going to select the one in the middle. Then I can see where I'm at. Okay? So I'm just going to take 11.2 times 11.2. That's 4, 2, 2, bring down a 0. 2, 1, 1, bring down 2 zeros. 2, 1, 1, there you go. 4, 4, 5, 2, 1. I have two decimal places. 125.44. Square root of 125? Why did I do that?
Why did you just square? It was like 2d5 plus 100 equals c squared.
Uh-huh.
So isn't the c like 125 and c squared?
No, c squared is 125. So whatever c is, I square it, and I got 125. Understand? So what reason are you asking why I took the square root?
Yeah, I'm asking why did you just...
Say it's 125?
Yeah.
Okay, well think about it logically, okay? Let's look at it logically. Is there any way that this side's 125 feet if the other two sides are 5 feet and 10 feet? Okay. So it can't be 125. It's got to be something similar to 5 and 10. So if I don't take the square root of it, then I'm not going to know the actual size. When we take the square root of it, because of these right here, since I squared those, okay, that's what 125 equals. So if I have 125, I want to know what C equals. I don't want to know what C squared equals. I want to know what C equals because we're trying to find the actual length of the side. The actual length of the side is not 125. The actual length of the side squared, if I square it, is 125. And so I have to take the square root of 125 to find out what the actual side is. But, unfortunately, like we said, it's not a perfect square. It's not 11 times 11, it's not 12 times 12, so I have to go ahead and approximate it. When I approximate it, I get 11.2. I probably need to check 11.1 because I know it won't be 11.3, but I probably need to check this to see if it's any closer than 11.2. So as we check this one's easy to check because of all the ones. That gives me 1, 2, 3, 2, 1. So 123. So which is closer, obviously, to 125? 125.44 or 123? Yeah. So obviously, then, the answer to our problem is 11.2. Now, what you'll see in your book a lot is this. Okay? Instead of just a straight equal sign, you'll see the little S sign. Okay? And what that means is an approximate. Okay? What this means right here is approximate. Huh? Well, you really need to get in the habit of putting that because the answer is not 11.2. Okay, that's as close as we need to get right now. But you don't need to understand. You need to understand that, in other words, when we squared everything, we didn't get 125.44. Okay, a great example of that, great example of the Pythagorean theorem is if you think of I got it up here. I forgot. If you think of a baseball diamond, and this is first, second, third, home. Okay, if I split that diamond right in half, okay, if my picture was a little better, I squished it too much this way. In a real baseball diamond, this triangle right here is going to be 90 degrees. Okay, and you can use what we're learning here plus, and we can find the distance from home to second by using some of the theorems that you're going to learn about right triangles and other things like that. Okay?
So what is the Pythagorean theorem thing doing?
Its purpose is to help you find the missing sides on a triangle. Now, most of the time, it's going to give you a perfect number. Most of the time. When it doesn't, we could carry that out. In all actuality, let me pull up my calculator here. See what the actual square root of that is. Let's see, 125, right? Is that what we had? Yeah, the actual square root of that is 11.1803398874989. That's the actual square root. But instead of using that, we approximate it to the nearest tenth, which was 11.18 is what, that's what your calculator is going to come up. We're just going to round it to the nearest tenth. But since we don't use calculators in here yet, then we've got to have a way to do it. Now, obviously, most of the tests you're ever going to take are going to come up with that. Now, Pythagorean theorem will be added into some stuff later on that will help you identify the other angles of the right triangle. So you'll use it as a part of another theorem, and the two theorems together will give you the information on. So you can be given one angle, but of course, obviously, you have to always have two sides. In other words, if I had three sides and I only give you one of them, it's impossible to figure out what the other two are, because you can't have two things. Well, it's not impossible, but right now it is. Okay? So that is the whole point of the Pythagorean theorem, is to find distances of a right triangle they're missing. Now, in your achievement test the other day, they did some kind of, if I remember right, it was wasn't it like 2 towns or 3 towns? Wasn't there a problem on there, like 3 towns? They wanted to know the distance. If you you had like a town. They basically did something like this. There was a town here, and a town here, and they gave you the distance there and the distance there, and they wanted to know between those 2 towns. Okay, well, that's just A, B, C, whatever the distance was here and here, squared, and then you take the square root of that, and that gives you the distance here. And it was a whole number, obviously. They didn't give you you didn't have to approximate square roots, luckily, because y'all didn't obviously know how to do that at that point. So let's look at this one. I want you to do this one on your own. You have a triangle. Okay, and the triangle is 5 inches and 7 inches. Okay, and we want to know C. Okay, so figure out what C is. All right. Who's got something? Laney? 8.6. That is correct. Okay. Take 5 squared plus 7 squared equal C squared. Okay. That's 25 plus 49 equal C squared. 25 plus 49, what? 74, right? 74. All right. Okay. So now we got to take the square root of each on each side, each term. Square root of 74 falls between the square root of 64 and the square root of what? 81. So that's what it falls between. So this is 8 and this is 9. Okay? Now, 74 is almost halfway in between. Okay? Almost halfway in between the two numbers. Okay? So you're looking at 8.4, 8.5, 8.6, probably not on the 8.4, but in the 8.5, 8.6, because it's literally almost, halfway in between. And, well, it's 10 away from that and 7 away from that. So it's actually leaning toward the 81 side. So it for sure is probably one of those two. When you multiply it out, you're going to see that it's 8.6, and that would be inches. Okay, so that's what C is equal to, 8.6 inches. Look at something right quick here. All right. Your homework. Still got about 10, 15 minutes left in class. I'm going to let you break into groups, start working on it. 11.3, 1 through 17, and 29 and 30. All right, obviously that's due tomorrow, okay? So you can break into groups, start working.